今天参与我们的这个分论坛哈。我们今天分论坛的名称是智慧供水及调控技术新世代的解决方案。那非常谢谢大家今天百忙中拨空参与哈，午安。那我是朱敬平。那我想今天先请大家能够就是说了解一下，我们今天因为其实有邀请2位国外讲者不过因为就是说国际间新冠疫情的一个关系所以我们有2位讲者呢，国外讲者，一位是在东京都，一位是在澳门我们是先请他们预录好影片然后在现场做一个播放。好，那其他我们另外还有2位国内讲者就是在现场跟我们分享他的经验。那这场那个分论坛是由就是水利署跟自来水协会这边一起进行合办的那我想这边我们是不是先请自来水协会的吴阳龙吴秘书长先为我们说几句话，欢迎。
另一位主持人我们的张副总，还有讲者我们的那个赖副署长，以及黄教授，还有我们这个自来水事业处的那个陈处长也来了各位这个与会的这个专家还有贵宾大家好。那今天会有这个议题最主要是水利署办这个水论坛的时候，来跟自来水协会来谈说到底要用什么主题会来。OK， 会来这个在这个论坛来讨论的话会比较好。就刚好水利署最近在推前瞻计划的时候，把这个智慧水网这一块放到它前瞻计划的一部分那目前补助了像马祖水厂金门水厂、台北自来水事业处以及台湾水公司在推动智慧水网这一块。所以说我们这次呢，就把这智慧水网放在我们这个议题里面那其实在整个智慧水网里面，它其实分为3个主要的部分最主要是智能设备，就是说我们所有的这些从水源一直到用户端装了很多的这些监控设备也好，监视设备也好，这边都是这些设备呢，就是要帮助自来水事业处在整个这个系统的这个过程中，怎么样是起到掌控整个的状况那另外一个重要的部分就是就是智慧网络这部分我们发现要把这些监控设备的这些资讯怎么样把它传到这个自来水事业的这个监控中心也好，或是他们 SCADA 的系统也好，他们有一个非常重要，就是要透过这个传输，所以这个网络变成很重要。像马祖这一次他们在推动这个智慧水网的时候，他们是用中华电信来当主标，因为他们发现在这个传输这一块，如果能够掌控得好的话，那这个智慧水网的这个建制就会比较顺利一点。那另外最后一个就是数据的处理，这些传回来这些资料怎么样做分析，怎么样去展出你想要的资料，对你的整个系统的管理跟掌控有什么帮助所以说我们在推动智慧水网这一块，它最重要的是说我们希望怎么样？希望它的量测更精明，不管我们装智慧水表也好，我们做这么多的量测设备也好，我希望它的是能够精准，而且是明确的能够传到我们所需要的这个资料另外呢，它这个传信系统不要是断断续续，到底要多久传一次，或者是说随时要传这个部分，你整个这个网络系统一定是要非常的这个越来越好的时候，才是有办法把这个资讯的这些传信能够让你的收集，然后呢，你收集这些资料，你要很容易的去分析，然后它的分析的结果很容易的用可视的这个表示，比如说图表或者是你想要的这些结果能够展示出来。那最重要的，我们这推动智慧水网最主要的目的是什么？我们希望能够增加收益，增加收益，不管是降低漏水也好，增加这个水表的准确率，然后增加你的收入也好，还有就是你节省的能源也好，这一块部分就是你增加收益的部分。最后呢，我希望提高你们的管理的效率这个部分就是我们推动智慧水网的最主要目的。最后我们有这个图可以很明确的看出来，我们从整个水源开始一直到用户端里面装了这么多的监视设备以后，我们最主要目的是什么？能够达到我们能够像我们的这些 管理也好，或是这些风险的降低也好，或者是甚至于说我希望能够增加这个水压的控制也好，或增加了这个降低漏水率啊，这种种这些成果哦，就是我们今天要讨论的部分。那这是我们在这个过程中，我们是邀请到这个东京水道局哈，这个Tanimoto桑跟那个澳门这个自来水公司的这个李副总经理哦，他们来谈他们的经验哦。那这个部分呢，这是比较可惜，就是说我们台湾的这些自来水单位都没有来邀请了哈，所以这是完全是以国外这2个公司来谈。那另外我们那个赖副总他是谈有关于这个盐水，就是我们水源这一块。那另外我们那个黄教授的部分，他谈到在这个整个的情况之下，这个水会哦，这个应该是怎么样来计量会比较好？那我们是不是请这个另外我们那个张副总来主持我们下面的一个这个论坛？谢谢各位。
各位先进各位贵宾大家午安那这边先代表水利署跟自来水协会，就谢谢各位的参与那我想大家都知道了就是我们最近遇到非常多的这个不管在水资源的管理或者是调度上面都遇到非常多的挑战了那所以这个在我们来讲说，这样怎样让每一滴水都可以用就最好的利用，那它有没有什么更有效的管理方式跟经营方式这都是我们今天这个会议的目的希望各位先进在这边的能给我们提供一些意见让我们有一些交流的机会那当然这边也北水处的这个处长在这边我也知道北水处推这个管网是推得非常快的了那连我们的钱他们都不要了他们都自己在推那而且推到家户的部分所以这个部分也是我们的努力目标之一了那我们今天来讲的时候，我们今天在这边呢，我们第一个阶段会有2场那第一场刚才这个吴秘书长有讲，就是我们东京的这个东京都的供水处的处长，他会做一个简报那他的题目就是 Smart Solution for Water Supply in Tokyo。那我们大家都知道，东京的这个水道管理还有它的用水效率都是世界上称赞的了那我们很多同仁或者是单位都到东京去学习，或者是观摩都有那我们这一位讲者这个叫古本处长那他本身是在这个东京都水道局的供水处的处长。那按照他的履历来看的时候，他从1984年就开始从事这个有关于水道的工作，所以经验是非常丰富的。那他也说，他不但在这个管线的部分，那在这些 facility 就是这些工厂的部分，还包括未来的 renew 跟那个他的一些新的计划里面他都有参与很深，而且他在管理面呢，他也做了很多年的这个研讨所以他的经验应该是非常丰富的那我们因为他人不能来，所以我们给他有预录的 video tape。那等下 panel 的时候呢，可以跟各位用线上在 panel。如果各位等下有问题的时候，等下请把问题留下以后呢，等下他们这边可以直接请我们的后面的传译者帮你们翻译，然后在上面去跟他们做一个交流那我们现在就听一听这个古本处长的简报。那谢谢大家，谢谢。
好谢谢张副总。那我想我们接下来就播放那个 Tanimoto 桑Tanimoto 先生，东京水道局的 Tanimoto 先生给我们预录了一个影片那题目是 Smart Solution for Water Supply in Tokyo 东京都的智慧供水解决方案。
いいですか、じゃあ。Good afternoon, everyone. It's nice to meet you. My name is Tomoyuki Tanimoto. I'm honored to be able to speak to you today, and I'm sorry to take part in this conference by the video. Of course, as you know, the cause is COVID-19. In this presentation, I will touch on this point later. I'm in charge of water supply at the Bureau of Water Works of Tokyo Metropolitan Government. I have been involved in work related to water supply, including leak prevention, for more than 30 years, and I am now responsible for the water supply section. Today, I would like to speak about smart solution for water supply mainly leak prevention that we are currently undertaking in our future plan. In addition, I will speak about measures against COVID-19 and the use of ICT. I would be happy if my presentation could be helpful for all of you in your countries and region. As I have mentioned, my presentation is divided into 3 parts as follows. First, I would like to explain how to prevent from leakage in Tokyo. Second, I will talk about COVID-19. And finally, I will explain the use of ICT. Before we get into the content, I want to introduce the overview of Tokyo water. Please take a look at these figures. There are currently more than 13 million people live in Tokyo. With the exception of a few local governments, almost all residents in Tokyo use our waterworks. Our water supply area is about 1,400 square kilometers. The total length of distribution pipe is more than 27,000 kilometers. That is equivalent to roughly 2/3 of the circumference of the Earth. Annual water distribution volume is over 1 billion cubic meters. There are still more than 8,000 leak repairs a year. Tokyo is the biggest city, and we are biggest water utility of waterworks in Japan. And I work with over 3,700 staff members. Now let's move on to the first topic. I'd like to ask you a question now. Please guess, what is the water leakage rate in Tokyo? A, 20%. B, 10%. C, 3%. Please think about it. Please take a look at this graph. The correct answer is C, 3%. In Tokyo, the leakage rate reached a hefty 80% after World War II. Emergency restoration after the war helped the leakage rate drop to 30% by 1949. The leakage rate was gradually reduced, and in 1982, it was down to about 10%. And in recent years, it is kept to about 3%. Relative to the scale of our huge utility, we have one of the lowest leak rates in the world. So, what kind of initiatives are necessary to maintain our current low leak rate? First answer is early detection and early repair of water leaks. In order to find underground water leaks, we conduct works called planned work. Specifically, we place a listening bar on meters of each customer to check for leaks of supply pipes. And we conduct leak surveys of distribution pipes by listening the sound from street surfaces. The sounds from vending machines and sewers are also heard from the ground, and therefore, very experienced technician is required to tear them apart. Another method for finding the position of the leaks is correlation water leak detectors method. We use these devices by placing sensors on 2 places, such as the valves on water distribution pipes. We can find the location of leaks by measuring that gap in time to reach each sensor. This method detects leak sounds directly from water pipe bodies, so it is possible to conduct surveys without being affected by urban noise or the depths at which pipes are buried. Normally, wireless communication distance is about 100 meters, and they can perform measurement about 200 meters at maximum. Let's move on to next answer. Second answer is improving pipe material. We have improved supply and distribution pipe material. In the past, our utility used lead pipes for water supply pipes on the roads. However, lead pipes are weak and corrode easily, so we switched to stainless steel pipe. Currently, we use stainless steel products not only for pipes, but also for snap tap and valves. All materials used on the roads have been certified by our utility in advance to ensure product quality. Also, we are gradually replacing distribution pipe from weak cast iron to strong ductile cast iron. In addition, we wrap polyethylene sleeves around the pipes to prevent corrosion. As you know, Japan is a country struck by an incredible number of earthquakes. Therefore, we use earthquake-resistant joint pipes with strong seismic resistance. The high elasticity and disconnection prevention features enable the pipes to follow deformation of the ground during earthquakes. Now, let's move on to the second topic, our future plan about water leak. I will explain future plan from three aspects: smart meter, new detector, and data handling. First is the smart meter. The Olympic Village has already been constructed in Harumi area. This Olympic Village installed 6,000 smart meters for condos that will be renovated after the Olympic. And by the year 2025, 100,000 smart meters will be installed in various areas in Tokyo. In addition to these smart meters on supply pipes, we are considering the installation of smart meters on distribution pipes. This will make it possible to monitor the amount of water flow, direction, and pressure constantly. It's important for us to handle the data collected from new techniques. We believe that by combining data from these smart meters attached to water supply pipes and water distribution pipes, it will be possible for us to efficiently manage pipelines and speed up our response to water leak accidents. Next topic is introduction of more efficient water leak detection methods. In current water leak surveys, there are subjects that survey method feel dependence on human labor and difficult to hear leak sounds. The multi-point correlation leak detector is a survey device that we are currently examining. We have installed sensors on water control valves in multiple places on the road in order to find water leaks in a wide area at once. By introducing this equipment, it is possible for us to efficiently conduct water leak surveys and to detect water leaks without being restricted by the surrounding environment. In the future, we expect to be able to constantly monitor leaks without going on site by collecting sensor data on the cloud with improved wireless communication technology and by combining it with a mapping system. From here, I will talk about futuristic pipeline maintenance. Currently, we conduct pipeline diagnostic work for the entire Tokyo area. In this work, we survey the corrosion status of pipelines under roads and pipes under bridges and check the functions of valves and other equipment on site by operating them. On the other hand, we have introduced a GIS system called the mapping system. This system has functions that display the arrangement of piping overlaid on map data, as well as functions to collectively manage information such as the age, type, and diameter of the pipes, and predict the area of suspension and turbid water because of constructions. Our current problem is that the data obtained through the research and GIS system are not integrated. So, the huge amount of data is not reflected to the GIS system. As a result, there is concern that data will not be used when planning renewal projects as well as on-site work, and that leads to inefficient office work. In the future, we expect to be able to construct a new comprehensive pipeline maintenance management system by integrating evaluation data obtained from pipeline diagnostic work with the GIS system. By adding indicators of the degree of pipe diagnosis to the GIS system, we will be able to find weak areas of the pipe network by correlating with more detailed areas, soundness of pipes, and accidents. By implementing this new system into PDCA cycle, such as planning, management field, reflecting data, and verification, we will be able to efficiently execute maintenance work with limited resources. In order to utilize diagnostic made by experienced staff efficiently and permanently, it is important to view that we combine and develop existing pipeline management systems. In the future, it is also important for us to consider new possibilities of ICT and AI, such as the use of mobile devices, and introduce them to our pipeline management work. This is the end of first topic. Now go on to the next topic. Next topic is COVID-19, which is now the focus of world's attention. I would like to introduce 3 measures that we are taking to deal with COVID-19. The first measures are remote work and staggered commuting. In this February, when COVID-19 began to spread in Tokyo, many companies began to promote remote working. In particular, many staff members in my office, which is located in Shinjuku, one of the biggest cities in Japan, are working in their home. Second, we require them to change their commuting times, which helps to reduce congestion of public transportation, such as trains. The last point is about the prevention of infectious diseases. As you know, hand disinfection is considered an effective way to prevent infectious diseases. Tokyo water contains chlorine according to Japanese regulations and provides sanitary water. Therefore, we promote proper hand washing using tap water, which contributes to the prevention of infectious diseases. This is the end of the second topic. Now go on to the final topic. Final topic is ICT. I would like to introduce 4 measures that we conduct with ICT. In recent years, cashless payment with smartphones has become more and more common in Japan. So we have introduced a system that allows customers to pay their water bills via smartphone. This has made it possible for customers to pay their water bills with simple operations. Next, let's talk about ICT-based projects. In the past, plumber had to come to our office to browse water drawings. Now, plumber can search, view, and print the drawings through the internet. This allows them to view them even when our service office is not open. As well as browsing drawings, applications for new or modified water supply systems can be admitted via the internet. This system can reduce the waiting time for the water service provider's review. The Tokyo Metropolitan Government is working to open up administrative information. By providing Tokyo residents with information held by the Tokyo Metropolitan Government in machine-readable formats such as CSV files, the city is contributing to the transparency of the administration of new industries. Our utility makes various reports and water quality data available to the public. We have implemented a chatbot on our web page to respond to customers' inquiries 24 hours a day. A chatbot is a term that combines chat and robot. The chatbot is a program that uses AI to understand the meaning of a question and answers it based on a pre-prepared FAQ. Entering questions into the chatbot makes it easier for customers to access the information that they want to know. We have introduced AI into our customer service center so that we can respond appropriately to customer call. The AI automatically inputs the conversation with the customer in real time, predicts the most appropriate answer based on the content of the conversation, and displays it to the operator. This is expected to have a number of benefits, including eliminating the need for operators to search through a vast amount of manuals for answers, reducing the learning curve for newcomers, and eliminating the need to put calls on hold and keep consumers waiting. I hope that my presentation will be some assistance to your countries and regions. There are 10 months before the Olympic and Paralympic Games. I look forward to seeing you in person here in Tokyo. This concludes my presentation. Thank you for listening, and I look forward to seeing you in the discussion later.
那个等一下的话，如果各位有什么要请教的哈，那就麻烦把问题先写下来哈。那我们现在准备进到第二场哦。第二场这个是，这样要进到他的那个 video 里面。好，第二场呢，我们的题目是 Policy Integrations of Water Pricing in Response to Climate Change。那等一下是由我们的黄教授来跟我们这个主讲哈。那黄老师他本身以前是在清华大学教授哈。那他是两岸的这个经济就都有名的经济学家了哈。那早期我们在水利署在做这个水资源方面经济的时候呢，他就帮我们在做很多有关于水价啦，或者是水在产值里面的表现的这些相关的研究，所以他这方面是非常有名的哈。那我们就用掌声来欢迎一下黄教授。
谢谢张副总，还有我们秘书长，我们的赖署长，各位长官，各位同仁，大家下午好。首先我非常谢谢那个主办单位让我有机会来跟大家做一下报告。这个题目呢，事实上关于水价的问题，并不是一个很新鲜的问题哈，已经做了很久了。不过呢，今天我要做的这个报告呢，稍微着重于在于我们有很多不同的水资源定价的这种政策工具如何去做整合，所以我的重点就摆在这个部分。I was just invited by our organizers that our foreign guests couldn't listen to, catch our talk right here, so I was asked to talk in English instead. At the beginning, I was trying to speak in Chinese because it would be more efficient, but because of technical problems, I would decide to talk in English. By the way, 没有办法动哈 ，OK。Thank you. Yeah, and this is the content that I'm going to present to you this afternoon. First of all, I would like to briefly describe why I end up with this paper, and there are some facts or some situation that you already know, probably. And second, I would introduce to you also very briefly about the water pricing instruments practice exercise here in Taipei, in Taiwan. And then I will come up to some talk about the driving forces of market failure and policy failure. And both of these two failures are very closely related, and it also relevant to our topic today, smart water supply. When we are talking about smart, we need to be smart, not only physically, engineering, but also in terms of policy, okay? And that's why I'm going to talk about the integration here today. And finally, I will address a little bit about how we can integrate the policies together related to water resource pricing. Okay, and of course we can see later that there are so many different policy instruments, and to make them integrated together will be very difficult. And unless we have some some smart ideas, some smart equipment, and some smart tools, otherwise it's very difficult. And because of the topic here will be pretty much on economic theories or modeling. So today here I will skip this part to some extent and try to present to you in more simple ways, in the hope that you can make you understand better. And finally, there will be some conclusions. And the conclusions, I will draw 6 points of conclusions here this afternoon. And I hope these conclusions would be very helpful to most of you. And now, let's come to the first problem here, the motivation for this paper. There's several of them. Of course, the first one is related to the long-term and short-term of water stress. And the short-term we can experience, especially in recent months, probably this year. The water stress or water shortage is very stressful. And in the long term, there are some other reasons for water stress. We will come to that later on. And the second is the global warming, and the effects of global warming on water supply is already known, but the vulnerability created or caused by climate change is of great concern too. The water use efficiency, of course, has been a very important issue. Our chairman, our Secretary General just mentioned the importance of efficiency, water efficiency, how to improve the water efficiency. And the main reason why we are concerned about water pricing, of course, is partly related to water use efficiency. And then market failure and policy failures are very common in all kinds of markets, okay, all kinds of industries. And the problem is we have to understand clearly what kind of driving forces cause these failures in order to improve our water efficiency, policy efficiency, or use efficiency. We have to clearly understand what are the driving forces. So later on, I will give you some ideas about what's going on with the market failure and policy failure. And then decoupling. You already heard decoupling, this terminology, quite a lot. Not only the decoupling of environment pressure and GDP, but also decoupling of water and our economic growth too. I think this is also a very important topic for us to address the pricing issue. And then the Sustainable Development Goals, of course, underline the Paris Agreement or the proposed by the United Nations, is very important to us. And many industries are making a lot of effort trying to achieve this goal. And the nation, Taiwan also set some sustainable development goals for different industries. So is the water industry. And in order to achieve these sustainable development goals, we need some innovations, policy innovation, and institutional innovation, and enforcement innovation too. Okay. And finally, sustainable investment is very important. Probably many of you heard about ESG investment, right? ESG. And ESG as well as TCFD, both are very important factors that all the water company or water industry have to take this into account in management. So these are very important factors for us to improve our industry. And so because of this, we need to be smarter about our policy pricing and policy integration in the near future. Okay. And this, what follows are some slides that show you some the information about what we just mentioned earlier. Okay, and this is a global change, the global warming situation, okay, and this is the crisis or the impact of climate change. And I try to highlight all of them, and here you can see that the impacts of global warming on water sector or water industry could come from different aspects. Okay, extreme weather, heat waves, droughts, melting ice. We can see this later on. Okay, and this is the impact on recreation, because water is also a very important factor to recreation, and the impact of climate change on recreation is very important too. Although recently we did not pay much attention to this topic, the impact of climate change or global warming on recreation. But this is a very important topic for us probably in the coming years. Okay. And then this is the impact. I think you are already familiar with this. I would like to show, to mention, to see a few words about this photo here, the forestry. Okay. And I went this forestry last year before the COVID-19. Okay. I was there in October. At the time, a lot of our passengers on train are coughing. You know, I experienced that a lot. Fortunately, I came back to Taiwan safely. But this is a photo that shows the damage caused by extreme weather in Italy, just in one night. And this forestry, this site has been well known for 200 years. It's a commercial, it exports commercial woods, timber. Okay, and this is about the Antarctic. Probably, I would like to ask, how many of you see the picture in the right-hand side? The right-hand side. How many of you saw that picture? Yeah, it's quite amazing, you know. Probably I would like to show you.
Oh my God! Look at this run! Oh! Oh my God! Holy! Oh my God! Look at this run! Oh! Oh my God!
Okay, and this is this situation associated with the Atlantic South Pole here. And as we can see, the ice melting caused the sea level rise significantly, especially in this area, in this region. Okay, and the problem from this, not only the sea level rising, but also water supply. We can see another third pole. This is a third pole we call mainland China, 青藏高原, okay, and many water supply of the rivers such as Sangjiang, Yangtze River, Yellow River, and other important rivers for other countries. These important rivers supply fresh water for many Asian countries. But as we can see that this third pole might become totally demolished or melt in 2035. And by that time, if all the snow here, all the ice melts, then the water supply for these countries will become a very serious problem. Okay, and the water pressure on the global can be seen here. And here we can see Taiwan. Taiwan, although it's yellow, but that means it's also very crucial too. Okay, and the impact of the global warming on the water stress here in Taiwan is also very important. Okay, and now. The efficiency loss due to institutional or policy or market are also very important for us in order to make our policy more effectively integrated or make our water resource pricing schemes more efficient. And we have to look at all of these sources or driving forces that result in inefficiency. Okay, and here is a diagram showing how the water right allocation will affect our water use efficiency. Okay, and this is another picture showing the risk or the pressure, the stress or the pressure we have in water industry, rising costs, okay, of our water supply. And this is the water supply reliability. We estimate this a couple years ago. We presented this report in 2013 regarding the water supply reliability in the drought season, okay, in the shortage season. And from this diagram, this table, we can see that the supply reliability is quite low. It's as low as 60%. Okay, and in line with the climate change, we think the reliability could be even worse in the coming years. And this is a typhoon. We are lucky because this year all of the typhoon just passed by Taiwan. Although it's lucky for us in that sense, but it's also not lucky for us because we were short of rainfall, precipitation, because no typhoon. So the typhoon is sometimes it creates a hazard or damage to our society, but also it's very important to supply water to us. And this is, we are wondering because this year, although we don't have much typhoon coming to Taiwan, but how about next year? Probably it will be another situation. And this is the current water available in our major dams here in Taiwan. And we have these diagrams from the Bureau of Water Resource Agency. Okay. And from this diagram, because we can see that the water stress in Taiwan because of the typhoon disappearance. Okay, and now I would like to come to the water pricing schemes. Just a very brief introduction about this. There are several important factors relevant to the water pricing. Okay, the first one is, of course, the organizations. We have different organizations listed in our Water Act, and also there's a water priority of water use in our Water Act. Fortunately, we have some policy innovation in this aspect that allows us the priority to be more flexible in response to certain conditions, especially to climate change or water drought season. Okay, and water-related fees. The topic that I'm talking about today is much more on the integration of these subjects, these instruments, water tap price, water right fee, water excessive use fee, water excessive use fee, 耗水费, and loss compensation because of unavailability of your water rights. You cannot get enough water supply because some certain situation happens, and there will be some compensation either from the water authority or from other demanders of the water company. Okay, and so our question, our purpose in this presentation is how can we integrate these instruments together so that the effects of this policy instruments when we are not contradicted with each other, and the effects were not conflicted with each other. And this is very important because we would like to achieve our main goals, for example, sustainable development goals, at the lowest cost. Okay, that is cost effectively. Okay, and how can we integrate this policy together? As I said, it's very difficult and it requires a lot of modeling works. And today here I will skip this. And then a little bit talk about the sources of the market failure and policy failure. And the driving force of market failure is very well known. You know, it has been discussed in textbooks. And the policy failure instead is less presented in some literature. But the integration of both of failures are very important, and I will show you how can we do this, not in big detail. Instead, I would mention to you some of the typical examples here in Taiwan. The first one is related to the waste paper recycling, and the second is the development of biofuels, and the third one is the policy instruments related to greenhouse gas emission. That includes emission trading, carbon tax, energy tax, and TREC. TREC means Taiwan Renewable Energy Certificate trading. Okay, and so this instrument, the integration of these instruments are also very important and also very interesting. We already built up some models for simulation for these different cases, and we hope that in the future we also have some policy integration, integrated model that will allow us to evaluate the integration of policy instruments. Okay. And then this is the driving force of a market failure, and I will not go to this in very good detail, you know, but I would like to mention an important factor here. This is overlapping generations, because the water policy has something to do with not only the current generation, but also the future generation. If this is the case, then the market, especially the competitive market, will not result in any efficiency at all. Okay. In other words, in that case, when we are concerned about the welfare over different generations, we need some intervention, okay, policy intervention or policy innovation in order to maximize the welfare of different generations. Okay. And this is very important. And this is a policy failure. There are a lot of different sources that will result in policy failure. And one of them I would like to mention here is the policy evaluation model, the failure of policy evaluation model. Okay. And when we are talking about the policy instrument integration, normally we need some kind of integrated model in order to evaluate all kinds of the impacts of all kinds of policy. Okay, but the model, as you can imagine, is not always perfect. In many cases, it's wrong at all. And if the decision making is based on the results from this wrong model, then we have come to big trouble. And so the problem is how to make this in good shape. A very typical example is a DSG model that has been used widely by many central governments, central banks in industrialized countries, including Taiwan. Although it's very simple and very meaningful and widely used by many countries. However, when the financial tsunami happened in 2008, okay, all this model fails in interpreting or in predicting the outcomes from this financial crisis. Okay, so that means we need, although this old model around the world, failed, but we shouldn't be frustrated at all. Instead, we need to clearly understand why it fails. And based on the understanding, we can improve the model to some extent. Okay, and this is what we should do also in the water policy issues. Okay, we will have to try to understand what would would be the problems we had before. As an example, the Water Bureau. Water Bureau also constructed some kind of policy variation models before, but we can see that a lot of weakness in these models, and therefore some innovations will be necessary, especially the incomplete enforcement and the uncertainty. Okay, these are the very critical factors that we have to consider in the future for building the integrated models. And this is, of course, is another important sources of incomplete enforcement. And all of these factors really were rarely taken into account in our policy integration. And I would like to mention that, bring your attention to this subject. It's really important, especially the sources causing incomplete enforcement. One of them is the relationship between the central government and the local government. Okay, the integration, how to integrate. Okay, and as I mentioned, we need some smart policy framework for that, and it's very complicated, so I will not talk too much about this. But there are several important cases that we implemented before in Taiwan. Okay, the first one is energy tax. Okay. As you can see, it involves a lot of modeling work, and the second one is the waste paper collection and recycling. Okay, a very complicated situation. It involves subsidy, involves tax, income tax, involves compensation, etc. A lot of policy instruments all coming together and supported by different interest parties. Okay, the problem is from the government point of view, how can you integrate or coordinate all these kind of instruments together? And we have these suggestions recommended to the government before. And another issue is the development of biofuels. And we can see the development of biofuels, for example, the alcohol or the biodiesel. Okay, and it requires energy crops from agriculture sector that is strongly supported by the Council of Agriculture, Ministry of Agriculture. And the products is manufactured. The energy crop is used by the energy supplier as inputs and to produce biofuels. Okay, and at the same time, there are some importers that directly import biofuels from foreign countries. And by doing so, it's subject to some import tax, okay? And the Ministry of Finance is responsible for collecting this tariff. And also the Ministry of Finance is also responsible for imposing energy tax on all the oil suppliers. And as from this diagram, you can see that a lot of government agencies, including Council of Agriculture, Ministry of Industry, EPA, and the Energy Bureau, all involved in this development framework. And they have different policy instruments. The problem is how can we integrate, coordinate all the policy instruments so that the effects would be more cost-effective. Okay? And this is an example. We also have this model built and several simulations implemented. Okay, and this is another policy framework for water supply. Because of time constraint, I will not come to detail in this part. Okay, and this is some of the framework just show you how the modeling could be completed. The same for this. Okay. Because of the time, I will now come to my major conclusions. The first of all is the integration of policy is very important. Okay, it's not only an economic problem; it's also a social problem. Okay, and resource problem. It has a significant impact on the society. Okay. And then the integration of policies, although very complicated, but it's operationable if we can join together and to investigate in a more harmonization way, then we can end up with some model that will allow us to evaluate in a more effective way the impact of climate change on water supply or water efficiency. Okay? And incomplete enforcement is always prevails in many sectors, including water sector. And the problem is when we are doing policy integration, how this problem could be taken into account in incomplete enforcement. As we can see, a lot of different forces causing incomplete enforcement. And this is a policy integration requires integrated model, and I just mentioned this before. Okay, and another important conclusion I would like to make is water policy should not be independent of macroeconomics policy. Okay, because from the experience of the financial tsunami, we can see that the macroeconomics, macro policies are very relevant to many policies, including environmental policies, energy policies, and also water policy. And the problem is how can we integrate all the water policy into our national policy or our macro policy. Okay. And this diagram is showing the linkage between this. And in the last presentation by Mr. Tanimoto, he mentioned a lot of new technologies applied in the water industry, especially the monitoring of water leakage. And in the face of the fourth industrial revolution, we also know that there are so many newly emergent technologies available. And all of this, many of them could be deployed to improve our water industries in terms of not only policy integration, but also water use efficiency. Okay? And this is an important topic that we need to put more efforts on it in the future. And decoupling, I just mentioned, decoupling of environmental pressure from the GDP. Many governments are very reinforce the importance of this linkage. And in water sector, we hope that we can put more emphasis on this subject too. We are interested in not only the resource decoupling, the environmental impact decoupling, but more importantly, we are more interested in the welfare decoupling. Okay, when we are using more water more efficiently, at the same time, we hope that the benefits created from this use could improve all of our generations. Okay, and finally, there are a lot of challenges in the newly era that includes how can we deal with change or the role of water resources in our new society. Health is one of the important topics. As Mr. Tanimoto also mentioned, the COVID-19, and it's also very much related to water resources. Also, in the future, how can we build a linkage between the two? Okay, health, time, energy, and some other aspects, macroeconomic policies, or macroeconomic variables to quantify the well-being loss of climate change and health. Okay, and all of this, although it's not traditionally, previously, it's not a topic in water resource, but in the coming future, we think the integration of other areas are also very crucial. Okay, and new challenges to CZ modeling, as I mentioned, the integrated modeling, also very important to avoid the same mistakes we made before. Or we have to cope with the new industrial revolution, okay, to deal with the demographic change. Okay, and we all know this very clearly. And finally, to integrate uncertainty and discrete choice. Okay, and all of this will not be done here. We hope in the coming future we can have our integrated models more completed, more comprehensive, so that many of the factors could be integrated in our model. Okay. Thank you very much for your attention.
谢黄老师哈，谢谢黄老师。好，那等一下如果有什么水价的问题哦，等一下中间有一 break 嘛，也可以请教一下黄老师哦。好，那个就麻烦你。
好，谢谢各位。好，那谢谢黄老师。好，也谢谢这个我们刚刚东京都的那个塔尼摩托厂的那个简报哈。那我想这样子，现在是我们的中场休息时间哈。那我想请各位就是移驾到外头，我们有茶点可以享用哈。那我们时间是到那个，因为我们已经稍微晚一点哈，所以我想我们大家是不是在15点30分左右哈，我们回到我们的会场这样子。谢谢各位，谢谢。 张荣吴秘书长哈，那帮我们说几句话，谢谢。
好，各位大家好哈。那接下来的话，我们是由这个澳门哈的 Jackie Lai， 他是澳门水公司的副总经理哈。那他讲的题目是The Smart Water Evolution and Improvement of Macau Water 哈。那他这个 Jackie Lai 啊，他是毕业于伦敦的这个帝国学院。那取得这个环境工程的学士跟硕士的学位哈，那他现在负责是整个澳门水公司的这个他们叫做core technique， 就是他们的这个比较属于中心的这些技术的哈。那他在这个network 跟那个 NIW 这个方面呢，他有这个大概有10几年的经验哦。那这部分在推动于这个Smart Water 里面都有相当关系。刚刚我们上一场听到那个东京水道局那个Tanimoto 桑哈，他讲这个漏水这一块，其实它就是很多是 Smart Water 上面的应用哦。那我们是不是以热烈掌声来欢迎这个Jackie Lai？OK。
不好意思，请大家稍等一下。
Hi everybody, my name is Jackie Lai from Macau Water. Today I'm very happy to share with you guys the smart water evolutions and implementations of Macau Water. First of all, I would like to introduce a bit myself and a bit of Macau and Macau Water and the evolutions of smart water of Macau Water, and finally our conclusions. So I'm currently Deputy General Manager of Macau Water. I'm responsible for all the technical departments in Macau Water. Also, I'm a chairman of Health and Safety and Innovation Committee in Macau Water. I'm also a senior management team member of Hong Kong Pillar Pond Wastewater Treatment Plant and currently a core member of IWA China Water Loss Task Force. Where's Macau? I think most of you know where's Macau. Macau is the south part of mainland China. So we are the special administrative region like Hong Kong. Macau is a very small city. We only have 33 square kilometers, very small area, but we have a lot of people. We have more than 670,000 people. So you can imagine how dense is Macau. And the main economic industry is the tourism. We have a lot of casino in Macau. Macau is a joint venture company of Suez NWS. Suez NWS is a joint venture of Suez and Hong Kong NWS company. So they hold 85% of Macau water. Currently, we have 3 treatment plants in Macau. They add up together 390 MLD. And at the end of this year, we have another 130 MLD. So we add up to 520 MLD at the end of this year. And I give you some figures. Nowadays, we are producing less than 300 MLD a day. Let's talk about the overview of smart water evolutions in Macau water. So we know that every functions or workflow which is from westernizations, and then they will move to standardizations. We have to make the standard for every procedures. After standardization, we move to documentations. That will be something like ISO 9000, something like that, ISO standard. And after that, we have to do the digitizations. Digitizations is the fundamental for smart water evolutions. So only the digitization is not enough for smart water developments. So we have to base on the automations and modeling. So based on these two stages, we can do smart, and we're still far away from the artificial intelligence. So Macau water, we are mainly focused on digitizations combined with automations and modeling to achieve smart waters. And after mature enough for smart water development, we will move to artificial intelligence. So digitizations, we can subdivide into mass data management. So every water company will dealing with a lot of data. So mass data management is very important. We got the data, we have to be visualized those data. So BI visualization is also a very important part. And combining with our know-how and our expert from the staff. So by use of the automations and modelings, so we can achieve the smart water. But we have to think of why we need to do the smart water. We have to have something like an objective of doing smart water. So in Macau water, we have three main concepts or objectives trying to achieve the smart water. One of them is the cost optimizations. The other was process optimizations. And finally, we have to increase the customer satisfaction. This is the main driven for us to doing the smart waters. So Macau water, we divide the smart water into three sectors. One is the smart operations and smart distributions and smart services. So these three categories, they will have their something like subtitles. For example, in smart operations, we will have some sub-projects like smart alarms, smart dosing, and plant maintenance systems. For the smart distribution, we will have advanced water network systems, etc., etc. I will introduce you certain cases of smart water implementations in Macau waters. In course of all of these three sectors, we will have two systems or two platforms. One is the integrated reporting system, and the other is the EAP, Enterprise Application Platform. I will elaborate a bit more in the following slides. And there also have two intersections between three sectors. So the energy management and water quality management, we also some intersection between those three sectors. Okay, talking about the digitizations. So we will have like every water company, we will have different source of data. For example, we will have SCADA data, we will have asset management data, I mean the server or system, and NIM systems, IC system, and financial system, and GIS system, etc., etc. So they are all quite independent to each other. So in Macau water, we create or we build something like a central database, trying to collect all the data, all the necessary data into this central database server. And then we will use the central database data to produce Power BI or BI. So the data source and database, we will call it mass data management, and the BI reports, we name it as BI visualizations. We have created a lot of Power BI in Macau Water. From the time being, I think we have more than 40 Power BI reports, and we are going to consolidate those Power BI in a systematic way. I will show you one of the Power BI usage in Macau Water. Here is the example of the usage of Power BI, and here is the 2-month data of NIMS alarm or alerts in the networks. We found out that there are 5 alarms in the networks for the past 2 months, and we locate one location, which is in Haksa village, which is the low residual chlorine issues. The figure is 0.03, which is pretty low. So we try to locate the upstream and the downstream of the Haksa village. First of all, we locate the Haksa village for the past 1 year data, the residual chlorine data, and then the upstream and the downstream. And we find out that the downstream and the upstream seems they don't have any issues, any problem. And we can conclude that the problem is the Haksa village sampling point itself. So this Power BI can help us to make up the decisions. And so we talk about the modeling. This is the hydraulic model with the quality model inside. So you will see that when we run the simulations, this is the whole network of Macau Water. So we can see different color represents different residual chlorine. So the red represents the residual chlorine more than 0.5 ppm, and we can identify from this hydraulic model, water quality model, the potential problems area. For example, in this Hanshin area, Hanshin University. So from time to time, we have to flush the networks, trying to keep the age of water young. So that is the decision making, I mean, through this hydraulic model. Okay, so besides, I mean, the data, master data management and modeling, we also have advanced water networks tools. This is quite advanced water network platform, and we know that the water coverage from different water treatment plants. You can see that we have 3 treatment plants, but we have 4 pumping sources at the moment. The red one is one of the treatment plants water coverage, and the other color represents different water treatment plants. And we can identify different hours, different period of time, the coverage will difference depending on the pumps operations and control valves operations. You see that this is a particular day at 1 o'clock midnight. You see 2 o'clock, they were very different. And 8 o'clock in the morning, 9 o'clock in the morning, 6 o'clock in the evening, 7 o'clock in the evening. So every hour we have different behavior, I mean, of the water supply coverage. And as you can imagine, we can also modify or monitor the different water supply velocity, head losses in individual networks by means of this platform. Because this platform, we embed the online hydraulic model inside this platform. So this is very useful for our operator and our network engineer. So we talk about before is about the data management and model usage. So combining with the automations, we can have something like a smart solutions. So this is a case of smart chemical dosing, which is developed by ourselves by Macau Water. So we combine the data and automations and modelings. So we successfully to achieve this smart chemical dosing. We have to take a lot of parameters from the treatment plants. We install a lot of sensors. So the project we started from 2017, and it takes about less than 1 year. We succeed to implement this smart dosing. Yeah. So we have to install quite a few of sensor, which is already installed. I mean, for our water treatment operations in Macau Water. So you will see that we have a quality sensor at the raw water, settled water, and clarified waters. So they will feedback those data to our automation systems, and also including the filter parameters, something like a filter clocking rates, the productions of plants, backwash of the filters, etc. So they combine together with the sensors, I mean, for the water qualities. So we can see that after 1 year operations, we have something like 30% to 40%, even compared to the previous years, previous 5 to 10 years. We have as large as 50% of saving for the PACL dosage. This is quite significant, and this is beyond our expectations, we can say. So another one, we move to an example of AMR, smart meterings. We install about 500 meters to cover all the Cotai city, which is a commercial area. Most of the casino and big hotel are in these areas. So we use the Suez solutions called FM169. We just install very few concentrator. They can connect. As you can see at this area, which is quite large compared to the whole Macau is a large area, and then only 3 to 4 concentrator can receive all the meters in this area. So we install about 500 meters here by 3 types of this concentrator. They can connect all the meters readings, and then through GMS transmissions, transmit all those 500 meters to a data server. The data server platform called EMIS. They are trying to collect and analyze the water's supply behavior, and also to detect any leakage inside the properties. So we successfully feedback to our customer. Quite a few of leakage happens through these systems. So this is also we kept our smart water sectors, and we have succeeded the integrate reporting system, and we have succeeded some smart solutions like smart dosing AMR. So I would like to talk about another sectors, which is the enterprise application platform. So as I mentioned before, in a water company, we will have different systems. For example, in financial department, we will have financial system. In laboratory department, we will have a LIMS system. network department, we have GIS. Customer information department, we have CIS system, etc., etc. But they are independent to each others. So few years ago, we are thinking to build this type of different system together for mobilities. We have we have construct this type of integrations. This is a bit complicated. You can see that. This is a linkage to each other through different systems. But we find out that this is not easy to handle, and this is not a very ideal methods trying to integrate so many systems through their linkage. So what we are doing now, I will show you that. For the data part, now we are using the central database, trying to connect the necessary data from different systems. So for the application part, we are using the similar approach. We are not going to integrate two systems, integrate together. For example, the SCADA system and the asset management system. We are not going to do that. Why? Because we are trying to do this. The disadvantage is that whenever we want to change the system to other brand or other solutions, it's very tedious and very difficult to bring the link together. So this makes us very difficult to do shows. So we are trying to use the similar approach of the central database concept. We will build up a virtual, something called EOP, Enterprise Open Platform, trying to connect, the different systems. Once we open their API, we can call out their core functions. We only use their core functions in order to do our workflow or our functions. So based on this EOP, we can create something like a EAP, Enterprise Application Platform. For example, when we are doing something like a customer complaint, we need to use the data or the functions of the CIS. And we also need to use the function of asset management for workflows management, work order system management. And if there's anything related to the networks, we also need to call out the function of the GIS. So everything, we put it into an open platform, and then we use applications to link these three core functions together. If we need to take out some parts or networks from the warehouse, we also will involve the financial system. So 4 different systems will combine together in and application systems. So this is a very good methodology. That will increase a lot of our efficiencies. I can give you some example. In Macau Water, we are developing some EAP applications. For example, we have done the application for productions, operations. Those are combined with our SCADA and our asset management systems. And we have something like a help desk, customer complaint follow up, which I just mentioned. We combine the CIS, GIS, asset management, also the financial systems, 4 systems together. And we have also some typhoon, health and safety, letter management, and safety inspections. So we are going to have more to come in the near futures. Move to the conclusions. digitization is the most important and it is the fundamental stage for developing our water smart solutions. So I can see a lot of water business. They don't even reach the stage of digitization. They may be in the stage of documentations, but they would like to develop the smart waters. That is not easy, and they couldn't succeed if they don't have very strong of digital data as their fundamental element. Also, mass data management is also important because we have a lot of data every day generated by the SCADA system or network management systems, or even we have a lot of customer information systems. So how we can manage our data, which is also key part for us, for the water company. And BI visualizations is also a crucial part for the time being, because we have data, we know the data, how they have something like a structure, but how we can present them in a systematic way, or how we can present them in a variable way. This is also very important. And also, the user of the report or the data user, they are the key staff or the key point for predefined, and even they have to construct the data format of the curve or report for a BI system, because most of people, they will think of IT staff will be responsible for dividing or construct a data format for the users. I don't think this is a good idea, because most of the IT staff, they only know the data server, data base structures. They don't really understand the operational needs. So the data users, things especially from the operation department, they have to divide, not only divide the structure of the data report, but also they have to do it themselves, because nowadays many BI solutions, they are very easy to use. In Macau waters, all the Power BI reports are defined by the users. IT staff just help them to bring the linkage or the bridge between the data and the BI reporting systems. And finally, EAP, we mentioned about that in the previous few slides. EAP will be the future trend for the cross-functional applications, because cross-functional applications is not only issues in water company, but also in many companies, which is obstacle, because we have to cross-department or cross-functional. So if we can build up something like that platform, that will increase our efficiencies, not only for the work efficiencies, but also for the process efficiencies. And that's all for my presentations. Thanks a lot for your patience. Thank you.
这个非常棒的简报，他把一个推动这个 Smart Water System 的这个发展程序都说明得很清楚。我想在座的很多自来水事业的同仁应该这个什么，这个很有这种应该是感同身受那种想法就是说， 发展的历程跟我们在推的这个智慧化的都很类似了哈。尤其他们在推动这个，因为某种需求，比如说 alarm system 啊，或者是多星 system， 或者甚至于 smart meter 这一块哈，这个都是现在这些事业单位在推的哈。那怎么样把它最后整合成一个可以让管理者啊，或者是用户能够受益的一个 smart water system， 我想这个是一个非常棒的一个简报哦。那我想因为时间的关系，我们是不是接下来听我们这个赖副署长的简报？我想赖副署长他是在水利署已经有非常久的这个经验哦，因为他在设计仁义潭的呀，或者是礼义潭水库了哈，有在这个水库安全评估方面，他有非常这个独到的这些经验哦。那他今天讲的这个题目最主要是谈水源在 smart 这个water 哈，在水源这一块的这个应用哦。那尤其在水利署最近几年哦，针对台湾这个因为气候变迁之下影响到水资源的这些管理跟应用上面哦，花了很多的心血哦。那赖副长又利用这个机会来把他们的这个成果跟大家做个报告。我们是不是以热烈的掌声来欢迎赖副署长？
主持人哈，2位主持人，还有各位贵宾，以及各位参加这一次论坛的女士先生哈，大家好。我退休大概2015年退休了哈，已经5年了哈，离开水利署5年了，但是水呢没有办法离开哈，因为水对我们太重要了，因为人类需要水哈，生物也需要水。我们的自然也需要水那所以水环境对我们实在是很重要也是我们的基础所以没有做好水环境的话，也就没有我们这个地球没有做好这个水环境的话，也没有我们希望这个台湾能够更好的话，也要做好我们这个水环境那这是我们这次这个整个的论坛来讲，是一个非常重要的一个课题那今年来讲非常的特殊，9月24号到现在台风一个都没有那我们举办这个论坛呢，更需要去加强这个论题那所以在这个整个这个主题来讲，大概我也是针对就是台湾的一个水资源的一个现况它的供需情形，然后谈论到我们怎么因应它的一个策略怎么样那后续呢，发现这些问题以后，那我们怎么做一个智慧的一个调控跟管理，以及安全的一个控制这是我们那个今天呢，我大概提到了这个主题跟各位大家来分享那大概有3个一个论题，就是现况了水资源现况，那还有就是我们的策略，最后呢提到我们的这个就是智慧的一个调控跟安全的一个管理那从这张图我们可以看得很清楚这张图大概是从1949年到2017年，那就是每年呢它年降雨量的一个状况台湾地区的那从中间这条线我们知道平均的降雨量大概2500个 mm 那在丰水年的时候呢记得以前平均的话大概3100个 mm 比较高那枯水年的时候大概1900，大概上下大概600，也就是它的标准差大致这样子那从这个1949年以后，那这几年呢大概经过68年，我们发现在这个期间呢，它的一个丰水年的这个降雨总量呢，逐渐的提高。我们可以看到，就是在 2005年的话，达到就是几乎到3600个 mm 哈。那枯水年的时候呢，甚至它降到在2002年的1500个 mm， 这表示我们的这个风遇风，孤遇孤哦。那这种状况呢，就是代表风遇风的话，那我们可能发生洪水的灾害愈大哦；孤遇孤的话，就让我们发现我们缺水的情形呢就会容易发生哈。那除了这个以外，我们也可以看到这个线里面，我们发现它这个风水年，它高峰的这个水量呢，它逐渐增加呢，它的一个期距啊，从19年啊一直荡到单位数啊，到8年、7年。那枯水年也是一样哈，一直降下来。那也就是说，原来呢20年发生一次，那现在变成7、8年就发生了一次。这表示说，这个我们本来是有异常的现象了，现在呢几乎渐渐的变成正常化。所以我们也要面对这个事实，怎么去因应啊？好，那这个是整个台湾地区的一个河川的一个特性，跟国际间地球上的一个河川的一个特性的不一样哈。那这一张图，我想大家都晓得哈。那台湾的这个河川的长度呢，大概不到200公里哈，也就是最长也只有186公里哈。那在国际上，比如说在莱茵河或者是科罗拉多河或者是湄公河，他们的河川的长度呢，就是长达呢大概1000公里以上哈，但是他们的高差呢，大概也没有我们的高，我们的高都高到3000、4000公尺哈。那所以呢，这表示说我们台湾的河川的一个特性哦，也就是它上游呢非常的陡哦，比1/100还陡。那陡呢会造成我们的一个水资源的一个情况呢，就是这个大雨或台风来的话，大概3天就流光了哦。那我们要去建水库呢，也很不好建，因为建的话，我坝高100公尺的话，我的容量才多少哦？最多呢也到5、6亿左右哦。那在国际上，它这个河流这么长的话，100公尺，那么它的蓄水的一个面积呢，可以达到2个州哦，几个州，所以它的水量是很大的哦。跟我们来讲，我们实在是天生的条件不好。哦，这就是我们台湾的一个特性哈。水资源的特性呢，那我们要知道了解水资源特性，才能够去找出我们怎么去解决的一个方法哈。那好，那这张图呢，大概台湾的一个降雨的特性呢，我们大概可以分成就是几个形态了哈。那每年它大概有4种这个形态会表现出来。第一个就是春雨啊，春雨呢就是每年的2月、3月、4月的时候啊，这个春雨呢发生，那它一定会给我们一些雨量啊。再来呢就是5月、6月，也就是给我们的梅雨啊，即使的梅雨呢对我们的水资源的利用是非常的好啊。再来呢就是7、8、9月，就是我们的台风的一个暴雨哈。那这个呢就是台风的暴雨，当然是占我们全省的降雨量是最多的哈。那后面呢，枯水期的这个部分呢，大概有就是我们东北季风的一个降雨大概这4个形态。那这4个形态里面，我们可以从这个它的一个降雨的这个柱状图可以显示出来。丰水期呢是5月到10月，那5月到10月呢，可以讲就是这个期间呢，就是我们的这个梅雨跟台风雨那所以在这个期间，它占的百分比有多少？我们可以从全省的这个降雨量可以显现哈。那在丰水期里面，它这个整个降雨量达到了78%，真正枯水期呢才占了22%啊。那以这个台湾分区来讲，大概整个全区还有中区跟东区呢，这3个地区呢大概差不多哈。但是差异最大了，也就是北区跟南区，它的差异是很大的哈北区来讲，就是因为它北部它有东北季风的影响，所以在枯水期呢增加了雨量，所以它的整个降雨丰枯的比例呢，也就从65%比上35%，所以它是比较平均的雨量，对我们来讲是非常好的一个水资源利用，也就比较不会浪费掉我们的水资源哈。那在这个 南部这个地区呢，由于枯水期呢，大概它的一个雨量非常的少哦，那它真正接受的雨量呢，大概都是丰水期，也就丰水期呢占了90%啊，那枯水期呢占了10%，所以它的差异很大。所以在这种差异的情况下，我们怎么去弥补水资源的利用？我们知道南部地区呢水库非常的多哦，也就是这个原因哦。好，这张图我们可以显示中间这个虚线图就是说它每年，也就是从2017年大概最近这4年那最近这4年呢，我们以每月的平均的雨量来做一个基准，我们发现那这个就是这个平均雨量每个月呢，我们去做一个对照比较那比较可以觉得在丰水期的时候，如果它跟着抬高的话，那就是这个洪灾可能会发生如果是枯水期的话，它降低下来呢，就表示我们有这个就是缺水的一个现象那从这边我们可以发现几个重点尤其最近4年来非常的奇怪那这4年来的我们发现，第一个就是春雨没有来的时候，那我们怎么办大概第1年的这个部分，那第1年里面我们发现台风有几次2次而已。我记得以前1年的台风呢，大概4次到5次平均现在的状况已经不一样了所以在这个2017年的时候2次，2018年呢剩下1次，2019年呢没有，2020年也没有这个就让我们要去觉醒这个气候的变迁呢对我们的影响多大那所以在台风这个部分也是一样。那另外呢，还有就是它不同形态的这个降雨，就是梅雨来讲，你看看2018年我们可以看得到梅雨呢是5月到6月，但是它梅雨呢就延后了，延后到7月到8月。那这个延后呢，那带给我们这个期间需要的水量呢可能就不够了所以2018年也是我们很严谨的一个时间点所以大家可以看得到这种情形呢，我们可以去预见，就是说丰水期可能我们会有什么洪灾，那枯水期呢可能有什么旱灾那这个我们可以做一个我们观测的一个指标那我们也可以去探讨怎么去做一个解决那这一张呢，我们可以显现，就是以增温水库为例也就是在2018年这个时候，那2018年在6月7号6月7号刚好那一次刚好是就是工程师节隔一天，结果呢是这个增温水库是最低水位的时候非常非常低，它呢这个水量蓄水量降到不到1000万立方公尺我们知道这个增温水库满水位的时候是5亿1000万的一个水量但是它已经降到不到1000万。我们知道这个增温水库的一个严重下限，最低的一个下限的一个水量是3000万立方公尺，可见那时候是降的已经到库底了从这个相片我们就可以看得很清楚那南水局也是非常的紧张了那还好老天帮忙因为这个梅雨是延后，结果还是有来那再加上一个热带的低气压，也就是8月23号的一个降雨呢，那让我们这个水量呢，它在经过3个月以后，结果呢水量降到下面这个已经满库了已经满库，就是升到5亿1000万的一个水量那所以在天后呢，影响到我们水资源的利用以及我们水源的这个安全呢，对我们实在是非常的一个重要好，那这张图我们大概可以看到就是2018年的这个状况。那这个2018年这个增温水库的一个，这个是它的一个年的一个历线图那这个也可以看到归线的这个部分呢，就是最低的归线就是浅蓝色这一条那浅蓝色最低这个就是蓄水量是3000万，它在这个2018年最低的时候已经降到不到1000万，可见这个严重性这个严重性，所以给我们的警惕。那我们要去做什么？ 因为我们已经有规线了。那这个规线呢，如果已经降下来，那我们的现在的这个目前的这个立线来讲，它如果这个坡度一直很快的话，我们要去解决，能不能让它缓一点？这是我们方案去解决的一个方针，也是我们要去解决的一些问题那所以这个也是显示我们整体的这个利用规线呢，然后如何去做一个调度还有调节的一些工作好，那这张图呢，我们大致可以了解其实台湾2500 mm 这个降雨呢，在我们36000平方公里的一个面积上，其实呢，每年平均大概900亿吨的一个水量那900亿吨的水量呢，它真正这个除了这个蒸发大概占了20%，也就是180亿吨的一个水量降下以后呢，剩下的80%变成一个表面水降到我们地球来。这80%里面呢，又有60%呢，结果怎么样？流到海里面。因为我们台湾的特性不一样，也就是它60%大概540亿的一吨的这个水量呢，就流到这个海里面去。这就是我们河川短那所以呢，3天呢，这水量就流出去了水库也没有办法蓄这么多那剩下的大概20%呢，就是我们要利用的，也就是180亿吨的一个水量。那这180亿吨的水量呢，那有些还好，我们做了水库，那水库呢，帮我们 keep 大概40万吨40亿吨的一个水量那这个地面水呢，我们靠着河川来引水，那也有100多万吨，1100多亿吨的一个水量那再加上因为降到地表以后它入渗，然后我们再从地下水里面取用所以加起来我们可利用的一个水量有180亿吨，这个一个大方向。那今天这个表格呢，是大概从2006到2015年这个整个状况，其实大致跟我刚才讲的是差不多，只是它一个上下的一个偏差而已其实这个水量呢，大概我们能够掌控，就是说，台湾地区如果180亿吨的一个水量你能够维持的话，那我们在整个来讲是我们的水资源利用大概会比较稳定一点好，那这是2016年的，我想大概刚才我讲到，就是我们刚才有谈到了，就是说这是它的供水那需求的这个部分了那需求的部分也就是一般我们在180亿吨的一个水量里面，就是工业用水呢大概占了10%那生活用水呢20%。农业用水呢30%也就是127那所以呢，在工业用水来讲，就是一年呢，它需求量就是18亿吨那这个生活用水呢，它有36亿吨那这个农业用水呢，大概有126亿吨的一个水量大概这个情形。那这个是2016年它大致的百分比，其实跟这个差异不多好，那我们知道这个需求量这个部分那我们可以从这个包括工业用水、生活用水以及农业用水的需求来讲那其实我们的生活用水，台湾的人口这10年呢大概没有什么变化也就是2300万左右的一个人口所以在生活用水来讲，大概是不会差异太大那这个农业用水呢？大概农业灌溉的面积呢，大致在30几万公顷的一个农田的一个面积那这个面积来讲，其实农业的这个灌溉的面积呢，目前是没有在增加但是减少也没有减少很多但是它就是也不是说也不会变成我们安全顾虑的一个地方那至于工业用水呢，就差比较大那工业用水各区呢的工业用水的发展也是我们的需求，那所以呢，就是工业用水增加了那增加的话，这个部分就是北部的部分。我们知道北部我们靠的水源大概2个很重大的水源，就是翡翠水库跟石门水库那翡翠水库 它的水量是蛮丰沛的哈，一年大概4季都有比较好的一个水量哈。但是今年好像也除了去供应以外哈，就是供应南调以外哈，那大概这个石门跟翡翠大概也不到50%了哈。所以也是今年算是蛮严谨的哈，蛮严谨的哈。那北部地区呢，生活用水还好，因为北部地区来讲，农业用水呢，也只有在这个桃园地区跟新竹地区哈。那生活用水来讲，北部的一个地区的人口占我们的这个全省人口算是蛮多的，它大概将近1000万左右哈，所以它需要的生活用水的一个水量是蛮多的，但是它是稳定的需求哈。那这个工业用水来讲，也是在桃园地区跟新竹地区哈。那最近几年，大概桃园地区跟新竹地区的工业用水，它有急迫性哈，那所以它增加量也很大，所以我们大概在这个情形呢，我们发生这个问题，将来怎么去处理因应呢？也是我们重要的一个对策啊。那所以这个是北部地区我们需要去探讨的一个这个问题哈。那这是中部地区哈。那中部地区呢，我们是靠着就是苗栗的鲤鱼潭水库以及就是大甲溪的这个石冈坝哈，那这2个呢，大概来靠着这个来供应我们这个中部地区的一个用水哈。那中部地区呢会发生的问题呢，大概2个水源呢，我们到目前还没有做联合运用也是我们要努力的一个方向跟目标哈所以后续呢，我们也会积极来做这些的工作哈。那除了这个以外呢，当然就是在丰水期呢。虽然水量有，但是浊度增高。但浊度增高的话，我们的生活用水还有我们一些需求的一个水量呢，那也可能没有办法去用到那也是我们需要去解决的一些问题好，那这个南部的地区那南部地区呢，大概主要是靠着就是曾文溪以及高屏溪那。以前大概最近完成的这个部分其实在整个水源来讲，就是南部地区呢，包括了南华水库、曾文水库以及乌山头水库这主要的水库那这个台南地区，那高雄地区呢，因为没有水库，要靠着这个高屏南河堰来做引水的工作那所以呢，这个部分我们尤其在高屏溪流域呢，因为它的这个河流的积水面积太大了所以每次的降雨量这么大的时候呢，那么我们真正流到海底的这个水量是蛮大的那我们怎么去克服那所以我们也要有一些策略来去做一个解决那所以在这个南部地区呢，当然也就是怎么去联合运用的问题那后续呢也有很多的一个解决的对策好。刚才讲到了，就是我们台湾水资源的一个现况需求那这个部分，然后后续呢，我们怎么做一些因应的一个对策那因应的对策，大概我们有一个大概4个大的方向那这个大的方向，记得以前我们在做这个水资源利用的一个第一个方向就是水资源开发，但是时代变了也就是说水源开发。大概可以开发的也差不多了那要开发的又影响生态那所以呢，这个部分我们只能做好这个规划的工作那最重要的，我们先着手就是我们既有的是不是可以，就是每一滴水都能够把它运用好那第一个工作就是节水那节水里面呢很多工作我们要去做努力的那包括就是尤其自来水的这个减漏的问题那这个也是我们重要的一个方向那以及农业用水的一个节水的问题，这2个方向都是我们重要要去处理的一些问题那产业的部分呢，当然也是要去要求，因为最后呢是产业它的需求所以有一些我们也去要求它怎么去做一个节水的工作然后呢，我们要做到这个我们储存的一个水库呢，能够做一个总量管制那这样呢，我们才能够做到一个节水的一个策略那节水策略以后呢，我们重点呢也放在这个调度虽然我们做了节水， 但是我们的这个既有的一个库存的水源，如果我们能够充分调度的话，那么我们可以把这些水呢充分的去利用，不会去浪费掉啊，不会去浪费掉。所以大概最近几年最重要的这个策略就是朝着就是节水以及调度啊这2个方向来努力哈，来努力。那后续呢有一些就是这个开发水源的部分呢，当然长期的部分我们也就准备做好了一个就是规划的工作啊。那短期开发的可以做的，那我们就及时的能够把它完成。那我们也在最近几年也完成一些及时的一个水源的开发的工作哈。那除了这个以外，当然就是备源的一个系统。我们知道，如果万一缺水的时候，那有一些备源系统，我们可以去帮忙去引领出来哈。那包括浮流水啦，以及包括我们的一个防灾的一个水井，那这是我们重要的一个策略的一个工作哈。所以我们在做这个策略的这个工作呢，我们有几个原则哈。那第一个呢，就是我们怎么去掌控哈，也就是我们怎么去超前部署哈。那在水利署里面，大概每年到了汛期过后，也就是每年呢大概9月底以后，那也就是台风过了。大概没有多大的一个雨量的时候呢，我们要进行检讨啊。那各区的一个水资源局呢，一定要先做检讨。那检讨呢是准备，因为没有水量了，那这些水量呢，我们在估计这些水量能维持到多久，明年要用了多久啊？那我们是不是能够达到我们供应的目标？那这个呢，一定要提前部署哈，也就是我们要做掌控的一个工作。那再来呢，就是我们要付诸行动啊。那既然我们掌控了，那掌控如果它是缺，那我们就要付诸行动，怎么去做啊？当然最重要的就是要做一个水库的总量管制的一个机制啊。那还有我们一些节水的策略也要随时来启动哈以及一些相关的调度的运用啊。那我们一定要把它处理好。最后呢，我们要做一个调整，也就是说，虽然我们去做这个检讨，但是随着气候的变迁呢，那我们要跟着这个来调整，然后做滚动式的一个检讨啊。这是我们几个的原则啊。好有关节流的部分呢，大概分成三个部分哈。那自来水的部分，重点还是在我们的漏水一个改善哈。那我们现在漏水呢，大概有15.3% 哈。那要到2031年呢，我们把它降到10%啊，10%。那这个可以节省大概1年大概有2.7亿吨的一个水量哈。那工业用水呢，我们尽量场内整体的一个回收率从70%呢，能够提升到80%哈。那这个呢，可以增加我们的水源量，大概有5000万吨的一个水量啊。那也充分希望工业用水呢，能够利用我们的再生水啊。那第3个就是农业用水，农业用水呢，我们这个农业用水来讲，其实它是比较有一些弹性的一个空间哈。那所以呢，我们就是估计它如果能够节水6%的话，那它可以大概节水呢大概9亿吨的一个水量，这是我们到2031年我们的一个目标。那整个来讲呢，我们希望说这个目标能够整个节省大概每年大概12.2亿吨的一个水量哈。那这就是我们大概到2031年能够达到的哈。好，那接下来就是调度的一个工作哈。那大概调度台湾区呢有18个区做一个调度区哈。那这个调度区呢，那当然就是我们这18个调度区呢，能够维持我们调度的原则，就是由内往外，也就是同标的呢，我们尽量在这个区域里面能够做好调度哈，往外调度。那 还有就是由近而远哈。那由近而远的话，那我们可以把这个不同就是不同这个标的的这个部分呢，我们可以做一些跨区的一个调度哈。那手段呢，当然就是总量管制啊，以及加强灌溉啊，还有就是水资源调度，以及增加我们的浮流水跟这个一个地下水啊。好，那这是北区的这个部分哈，就是我们北水就是南调啊，那南部呢南水北调啊，那我们这个北区呢，我们就靠着板2的一个计划呢，那能够把这个翡翠的，然后调到这个板新以及这个桃园地区。那桃园这个石门水库这边呢，它也可以南调到新竹地区啊。那这个我们的管线已经都做好了啊，所以这整个调度的工作呢，我们也能够很灵活的一个做调度。那南部的部分呢，就是高屏溪呢有丰富的水量的时候呢，那我们尽量把它调到这个台南地区来，让我们的增温水库这些的水量呢能够蓄存在增温水库里面啊。那现在呢，我们一些管线也积极在做哈，包括现在做的增温水库跟南化水库的联合调度哈，那以及这个高雄到台南的这个调度呢，我们也已经完成了。所以这个整个系统完整的话，那我们的调度呢会更完整哈。好，那这个调度呢，台南市的话，就是正常的话，就是南化跟增温呢都是45万吨一天哈。那到这个如果南化水库有多余的水量的话，那可以它增加60万吨。那这个增温这边少，那剩下的就蓄存在增温水库里面啊。好，那这个是水资源的一个开发哈，包括近期的开发，那以及就是我们中长期的开发。那这个呢，我们近期的开发尽量能够完成就把它完成。那中长期的部分呢，我们把它规划好。那如果有适当的一个时机呢，那我们就做好一些执行的工作哦。好，那这个呢，就是我们除了开发以外，水源的部分呢，就是水库的淤积。那水库的淤积呢，如果我们其实这也是开发水源哈，那我们到2031年，希望呢这个淤积的净沙量呢2300吨呢，能够就是我们清淤量到2000，剩下300。后续最终呢，我们希望就是入库的沙量跟出库的沙量是平衡的哦，这是我们最后的一个目标哈。好，那这个是备源的部分，也就浮流水利用以及防灾备源的一个水井。那这个呢，我们也积极完成了这些的一些工作哈。好，接下来是智慧调控哈。那我们有这些解决的方案以后呢，那所以我们大概这个整个降雨的这个部分呢，我们就用智慧的一个管理，包括上游的部分，包括它实际的监测的这个资料，以及我们监测的资料，我们怎么去做一些预估哈，然后预估以后，我们去做水资源的一个操作哦跟运用啊。这个呢是上游，然后到水库里面操作呢，我们也利用智慧的管理，让这个水量呢以及闸门排洪的一个能够用智慧化，能够达到我们那个目标哈。那最后呢，就是我们做到一个经济的一个管理哈，精致的一个管理，从预测，然后到日日监控，然后到严格的管控，最后呢，我们做灵活的一个调度哈。好。那这个是灌溉的部分，大概我们也是一样，从这个智慧的一个方向来走哈。那从上游到末端系统啊。好，那署里面呢，大概整个呢也是针对智慧化呢，那有一个就是我们的一个水资源的一个水利云的一个架构啊，让这个水资源呢能够这个架构呢能够把握我们气候的变化，以加速的管理，然后有效的运用每一滴水哈。那用这个大数据以及物联网呢，来及时来进行跨区以及跨标的的一个联合的一个调水哈。好，那这智慧水管网大概刚才水公司大概也有谈到这个部分，我就不再叙述了哈。那智慧的水网这也是一样哈。好，那这个是防洪的部分呢，我们能够以这个降雨的情形呢，然后去做防洪的一个操控，让我们的操控呢更安全啊，更合理啊。 好，这个是我们做了一个调控了以后，它一个规线的一个变化哈。好，那最后我做一个结论哈。那在整个台湾的一个降雨呢，在这个2500个 mm 这种情况下哈，那我们透过各标的的用水呢跨区的调度、有效管理呢，我们可以来稳定的这个达到这个供水的一个目标哈。那另外呢，我们因应这个气候的变迁呢，持续的来优化我们水资源的一个设施，以及中期的一个水资源的一个开发，包括就是再生水以及海淡水，还有备源的一个开发哈。那我们要达到这个开发，当然要充分利用我们的智慧的管控以及安全管理技术，能够导入提高我们这个水资源的一个真正的一个快速的一个决策啊，以及我们做决策的一个更正确的一个数据啊。以上就是我的一个报告，谢谢，谢谢大家。
好，那我们就直接进那个 Q&A 的那个阶段，那我们先连线。
我想，这个刘部长非常精彩的这个简报哈，让大家知道说，在有限的水资源利用上面哈，这个水利署发挥了很多的这个精神，在这个智慧调控跟这个很多设施的这种导入哈，然后让整个水资源能够有效的利用哦。那接下来可能是我们这个所谓的这个Q&A 的部分了哈。那现在是不是在哪些呢？是不是我交给这个主持人？
各位好，那我们现在先就是再跟那个2位国外讲者哈来做一个连线哈。那不过我想在这个阶段哈，我们可以先大家先我们先收集一些问题哈，是不是有哪位先进对于刚刚的4场演讲哈有一些相关的这个问题？
想有一个问题请教我们赖副署长哈，讲得非常清楚。那么就是这个调拨，您提到这个水资源的调拨扮演非常重要的角色，特别是提高水资源的利用效率这样。那么我的问题就是说，在从事这种调拨的过程当中，有没有碰到一些行政上面的一些障碍，特别是有关于这个补偿啊或者是什么的这些问题？谢谢。
谢谢哈。其实，在调拨的一个状况哦，其实也要建立一些机制了哈。比如说农业用水的话，那我们农业用水我们有一个调拨的一个机制哈，那移拨这个水量哈，那所以我们有一个补偿的一些办法嘛哈。那像今年来讲哦，水情这么不好了，那我中午在吃饭的时候，我就跟那个南水局讲，你明年有水可以用吗？哦。他跟我讲大概不行。我说不行，你就提早要去因应了哈。那所以就是像这种情况下，你需不需要用其他的一个方式？像这个，也就是说农业用水要不要休耕？那休耕的话就有一些补偿的机制，但是这个要提前要来大家协调那这样的话，让我们水源呢能够在这个明年呢有充分的一个把握，能够去供应我大概可以谈到这样子了哈。那至于这个跨标的的这个部分呢哈，其实也还好了，因为在自来水跟工业用水来讲是几乎都是在生活用水里面了哈。那所以大家协调，那能够节水这个方向来去做那大概是也比较好。那我们在做这个旱灾的应变的时候，当然就是会大家共同来协商来讨论
谢谢。那我们是不是有其他的问题？
我想请朱博等一下帮我翻译哦。我想请问，就是我们东京水道局的先进跟马靠水厂的先进，就是大家刚刚谈到就是智慧水网哦。 自来水管网的一些智慧管理。那我们都看到这个很美好的一个远景跟很正向的一个看法，就是未来我们可能可以管理更精致更好。但是我想请教，就是他们有没有可能可以提供给我们，他们在整个系统运作的时候，它的整个资源投入，就是经费投入的一些结构，因为我很想知道说 sensor device， 还有它的决策系统，还有它整个平台，最重要的是资安方面，它到底投入有多少？因为我们越依赖 ICT， 其实最怕就是万一shut down 或者是被骇客攻击的时候，我们整个系统就完全无法运作。所以我想了解它的整个那个资本结构到底是怎么样的一个状况。那也许现在也许没有办法马上有资料，但是是不是可以在会后再提供给我们这个参考一下？
Okay, there is a very big question for Mr. Tanimoto and Mr. Lei. This lady is asking about that when we talk about the vision of the smarter water pipelines, but what will happen if we will we suffer about the attack from the hackers? Okay, the computer hackers. Is this endanger our water supply stabilities? Okay, and the other question is how much money we should spend for setting up these sensors and also the subsequent maintenance. So I just wonder if Mr. Tanimoto can reply this question first and then followed by Mr. Lee. Thank you.
And so it is also difficult for me because now we are making the new plan for the future in 20 years. So we have two issues. We have two issues. The one is, as you said, the budget, because so Tokyo's population will be decreasing in future. So that the income for the government will be decreasing. But so our facility will become old and old, and they need repairing and rebuild, and then build a new modeling. So now I want to say to you that in the future there are concerns about the decrease in fee revenue due to decreasing in population and the succession of technology due to decreasing in staff member. In addition, it is necessary to cope with the development of information technology in recent years. In order to respond to these changes, it is necessary to issue appropriate corporate bonds, outsource business to private companies, group services with new technologies such as IoT and AI. So I can't say to your question directly, but now we are making the new plan, and the new plan is so next year. The new plan is on our homepage. Please look at our homepage. Yeah, that's my answer. Is it okay?
Yeah, Mr. Lee, it's your turn.
Okay, can you hear?
Yes, okay.
All right. Okay, for the questions about the if I got the correct questions about the investment for those smart sensors or networks. Is that the questions about?
Yes.
So if I can say that we should do it phase by phase or parts by parts, because if you want to achieve a very mature or very lot of sensors, then you have to invest a lot of money. But from the time being, I mean the current market, those sensors, I mean the cost for the sensors is keep going down. I mean the keep a very low price from the time being. I mean for those sensors. But there's another causes for the transmissions, the data transmission costs, which would be very large burden. I mean for water utilities. For example, if we have something like we have 260,000 meters. If we all have to install the AMR, I mean the transmission cost will be a huge number. I mean that will be the most cost we have to concern about that. I mean the investment for the smart sensors. But if I have to say that we have to have something like a strategic planning for the sensors deployment. For example, for the networks or for the flow meter or the network sensors, we are not necessary to deploy a lot of the sensors in all the networks. We have to have something like selections for the deployment. If we have a mature, I mean the hydraulic model, so we can decide which parts of the networks we have to design to install. That will save a lot of money for the water company. For example, in Macau Water, we have we are not very large network size. We only have 620 something kilometers of network size, and we have something like 30 flow meter and 20 something pressure sensors installed in the networks, and we are achieved to have something like a hydraulic model which have more than 80% of accuracy. So it really depends, I mean, of your knowledge about the networks. So the size of the sensor is really depends on that. And for the cyber security, I think that is a very hot topic from the time being. So in Macau Water, we have a IT department who is taking care of our all systems security, database and cyber security, and we just done something like a consultations a project for our cyber security, and we invest about 2 million. Size of Macau Water, we spent about 2 million MOPs. It's similar to Hong Kong dollar, 2 million Hong Kong dollar for our systems. They will provide us consultations, advice, and all the necessary, I mean the protections about our systems. I don't know if I answered the questions you asked.
Okay.
And that's it for me. Okay, thank you.
Yeah, thank you. 我很简单的先跟各位简单报告一下哈，就是塔尼莫特长这边有提到，就是说东京都也面临一样的问题，就是因为人口老化、设施老旧哈，那整个其实相对的来讲，我们收入会下降，所以其实需要政府的这个资助哈。不过这个大概不是长久之计哈，所以他们现在其实有在积极评估跟那个私人的机构哈 ，private sector 这边来做一个合作。那这个是 Tanimoto 上的那个回复。然后那个 Mr. Lei 李先生李副总这边的说明是说，他们目前来讲 sensor 装会越装越多，这大概会是也是要尽量避免的哈。他们有在发展自己的水力模型哈，那在一些比较关键的节点上面去装，那节省这个用量。那他们有专门的 IT 部门哈，那在投入很多的这个跟骇客的这个对抗的过程这样子。我先很简单的先跟各位报告一下。那不知道还有没有其他的问题？
Thank you very much. I have two simple questions to Mr. Tanimoto. The first one is you just mentioned that the COVID-19, right? So I'm just wondering how the COVID-19 affects the water sector in Japan. You suffer from that pandemic or benefit from this pandemic? And the second question is, nowadays the green recovery from COVID-19 is of great concern by many countries. So I'm wondering if in Japan any recovery or action plan will be taken in Japan in order to, facilitate green recovery.
I see. Thank you for your question. The first about the COVID-19. So I'm just an engineer, not a politician. So I say, so the problem is after the COVID-19, and so especially in Tokyo, the other issue is after the Olympic Games. Some time ago, I said that our population will be decreasing, so that our income will be decreasing. So how about the COVID-19? So the most important thing is the fusion, joining the technology and policy, especially about the COVID-19. So automatically technology and so human resources. The human resource, the human resource is the most important thing is the education and training to the human resources. And on the other side, the technology is based on the budget, as you know. But we have financial issues. We have also financial issues about income by the COVID-19 and the Olympic Games. So now we are estimating the income and budget. So after the prediction, we will decide how to decide about prevention and maintenance of our facilities. Now I just say the meanings. Can you understand? And the second, green recovery. Green recovery. So it's so difficult for me. So about the green recovery, let me check and research, and after this council, I will send you to the answer by the mail. Is it okay?
Yeah. Now, Mr. Lee, is your turn. Jackie, it's your turn. Okay. Did you have any comment for this, Jackie?
Yes. Can you hear? Can you hear?
Yeah.
Sorry.
Yeah.
I just
wonder if you have any comments for this.
Yeah. Yeah. All right. For the COVID-19, so I think we also have got affected by the COVID-19 pandemic in Macau water. So we have encountered something like work from home issues. So, but as we have something like we can use a lot of remote working. So we have as I showed you in the presentations. We have made a lot of Power BI. So even so we are working from home, we still can have update information. So the most important for us is for the repairing. So as I think it's similar in Tokyo and other cities. So if there's anything wrong with the networks or with the assets, we have the people to repair it. So this is the most difficult we encounter, during the COVID-19 pandemic. But luckily, in Macau, we only experienced 2 weeks work from home. And everything recover very soon. And from the time being, we only have 46 cases. And since, I think, 2 months ago, so everything is seems back to normal from in Macau. But we have, for the Macau government, they encounter financial issues from the time being because we couldn't have people to come. We still reject all the visitors from the foreign countries, except mainland China. They can come, but they have to have something like a test for the negative, and then they can come. But we lost a lot of international visitors. So that will affect our water sales. So we have to do something like trying to optimize our courses. For example, just now I mentioned about the chemical courses, power courses, and the workforce management courses. So that is what we have to do, to compensate a bit of the water sales decrease. I think that's it for my answer for that one. Yeah.
Okay, thank you. Thank you. Yeah. Thank you for the answer from Tokyo and Macau. 我这边简单跟各位报告一下啊，就是说这个刚刚提到这个 COVID-19 对这个东京都跟对这个澳门这边的这些自来水的这个收益哈，那我想在 Tanimoto 先生这边已经有提到，就是说啊，他确实是本来就已经在面临这个人口老化的这些相关的这个问题收益哈。那当然 COVID-19 这次也造成一个很大的一个影响啊，他们目前正在积极的也在研拟一些相关的对策哈。那我想澳门这边也是一样的情况哈。那虽然说有些东西可以用遥控的方式哈来做处理，但是毕竟有很多维修还是要现场人去做哈。那在本地的需求当然还是在，但是在来自大陆的旅客大幅的减少，来自国外的旅客大幅的减少的情况之下，对我们来讲也是一个很大的问题。那如何维持这个 asset 的就是资产这个部分，将是面临一个比较大的一个挑战哈。这样子 ，OK。那因为时间关系，我们再开放一个问题。那不知道现场有没有问题想要再跟各位讲者做交流的 ？Yeah, we are approaching 5 o'clock, so we allowed 1 more questions. Any questions?
不好意思，我想要请教一下，就是现在大概大家的方向都在采集用大数据的分析去做一个未来一个规划跟一个调配，也就是说达到一个效能的问题。那这部分因为人口老化之后，然后造成收入减少，然后但是我们一直在投入设备上的去建制，造成收入跟支出是不会平衡的。那不知道说在这一块的部分是不是有想到另一个方式，就是说在比方供水上的问题，就是说是不是一直我们在反过来建立一个叫做情境，就是像 Apple 一样，我们提供一个情境，然后让用水的方式改变，生活形态的方式改变。例如说，晚上我鼓励晚上使用水，那白天使用水的时候，水压会增加很多，那它就必须要打泵浦打什么，在水厂上制作上，那这个部分会造成资源。就是你要投入比较多的资源在白天，那晚上的话，如果说水，它去提供这些优惠，那水会更便宜。那大家使用习惯上，他们在做维护整个水资源的维护的时候，他们提供资源会变得比较算是比较就是会比较不用维护设备不用那么多，包含电的浪费。对，因为晚上电价的便宜，包含水压不用打那么多，同时间打那么多。那可以请教2位海外的讲者，这一方面的部分，他们有没有去处理这一块的部分？就是朝这个方向去想，就是 一个逆向方向的思考面去看这件事情。好，谢谢。
Yeah. Okay. Mr. Tanimoto, Mr. Lee, there's again another very big questions about. We all know that we are facing some challenges that we have to invest more for the something like the sensors or smart water management. But on the other hand, we may because the population decreased, so our income decreased too. So do we have some other way to solve these problems? Is it possible to have some new commercial models, or if we can have some other ideas to attract, to promote the people to change their water consumption behavior? For example, most people use water in the daytime, but we have to spend a lot for the electricity to pump the water, to manage the water. But maybe we can have some, we can change our water price or something else so that they may use the water at night instead. So using this way, we can sell the same amount of water but decrease our cost. Is there any idea for Tokyo and Macau to do this, or any other new commercial model? Yeah. But for Mr. Tanimoto? Yeah.
So, can you show the today's presentation with my slide? Can you? Please show the page 12. Slide page 12. Slide page 12. Yes, this is it.
Yeah, we have the page, we have the slide.
Yes,
12.
This is it.
Okay.
Yes. So now we don't think about the different prices and differences use volume night and day, but so we are in the future. So in a few or 3 years, so we have a planning about the installation experiment. This like so. So especially, please show the water pressure detector. The upper area. Yes. Yes. And the same sign is on down this picture. Yes, that's right. Yeah. In fact, this system will be calculate the water volume and water flow. So we will check the volume and flow in the several times. The normal time or national holidays or night and day. So that we will realize the way to use water by domestic using. After this experiment, so we will make the new plan for the distribute so new distribution type. That's all.
Okay. Yeah, Jackie.
Oh, okay,
yeah,
okay.
Yeah.
yes. I don't think we can easily to change the behavior of the customer to make them to use more water during the midnight. I don't think it is possible. I mean, in many cities, because it's the behavior. I mean, the habits of the people that are trying to use their water. And for the power or the tariff of the power in Macau, we do have differences. I mean, during the midnight and the daytime. And I think we can use another way, trying to save the power or trying to save the energy. It's something like high elevated water tanks. You can pump out more water during the midnight and storage in the water tanks. Because midnight, the power tariff is lower than the daytime. So then we can use the storage water to release more water from the reservoir to the customer during the peak hours. So that will be more feasible. And overall, I think we are talking about the optimizations of the operational power or pumps. And I think in the market, there's a lot of tools available for us to optimize our pump power consumptions, especially, I mean, in water company, majority of the power usage is the pumping stations. So the pumps combination scheduling, optimization of the pump scheduling, there are a lot of tools can help us to do something like that. But the point is we have to have the data. There are lots of data trying to help us, I mean, to make up the decisions, in which way the pumps combinations will be the optimal. So in Macau Water, we are using tools called Aqua Advanced Energy. This is exactly the tools we are using to optimize our energy. They can predict the demand in the following 48 hours. And we are calculate the most optimal combinations of pumps in order to satisfy the demand forecast. Yeah, I think that will be the way trying to optimize or trying to save our energy than other way trying to change the behavior or the patterns of the consumptions. I think that's my answer.
Okay, thank you very much. 我这边很简单，先跟各位报告一下哈，他们两边听起来应该不是他们节省成本的方法有一些做法，但是不是用刚刚讲那个改变用水的那个这个时间，不是把白天转到晚上去哈，不是这么做。那东京那边当然是透过刚刚简报，应该是我看应该好像是第13页那里哈，有提到就是说我们因为它在很多地方很多节点设一些水压的这个节测站哈，所以它可以知道有一些比较需要改善的一个点哈，它可以再改变这整个压力的这个供输模式。那 Jackie 这边提的也是很接近，就是说它这边其实因为一直都有对这个整个各个系统的这个 pump 的这个能耗来进行做一个监测哈，所以他们其实有做一些相关的一个优化。那另外他们有一些其他的一个储水系统哈，来做这个这个就是不同时间尖峰离峰之间这个水的这个平均，来达到这个节能的效果。大概是透过这个方向。Okay, thank you very much. For the variable opinions from Tokyo and Macau， 谢谢大家哈。那我想我们今天对整个议题都有一些相当充分的一个交流哈。那我想我们是不是因为时间关系，我们的现在目前整个时间已经是5点07分了哈。那我想今天的这个 forum 就到这里结束告一段落。那我想谢谢大家今天4个小时的参与，非常谢谢哈。那我也对这个连线过程有一些不是很顺利的地方，向各位致歉，非常抱歉，谢谢。那这边提醒各位哈，就是说那个我们外面有那个这个签到单哈，那如果各位有那个技师签证以及公务人员的部分哈，那就请再记得要做一个签退哈，那这样我们才能够获得完整的点数。好，那谢谢大家，谢谢。
OK， 拜拜。
拜拜。Thank you, Jackie. Thank you, Tanimoto-san. ありがとうございます。
Thank you very much.
Thank you.
Bye-bye.
谢谢啊，谢谢。